All right, YouTube, this is the Computer Alchemist, and I'm here to drop another PLC video on you. Since my new book came out, PLC for Beginners, I've been getting a lot of requests over LinkedIn to do a tutorial on how to integrate structured text and ladder logic. A lot of people still really love ladder logic. Obviously, it's probably the main programming interface of PLC programming in general, but structured text is the up-and-coming competitor to that. Guess you could call it a competitor anyways. It's essentially the wave of the future. If you want to future-proof your project, the best way to do that is with structured text. Structured text makes makes hard text simple by making your code much more readable and more streamlined compared to ladder logic. With that being said, people still want to know how to integrate and use their structured text modules in ladder logic. So this tutorial, we're going to kind of cover that. This is kind of the beginning of a heavy concept because this concept is going to lead into object-oriented programming, which is a very complex topic that takes a lot of know-how to do and leverage properly. However, we are going to have a whole series on that. It's going to I'm going to start rolling out over the next couple weeks or so, schedule allowing, and we're going to start diving into that. For now, we can put the object-oriented stuff to the side, but do keep in mind that is going to be a major factor in that in the future. For right now, after you create a new ladder logic project, what you need to do is you need to right-click Application, go to Add Object, and select PLU. Now, first thing we're going to do is give this a name. We're going to call it Comparer, and we're going to select a function block. This is essentially the backbone of your integration between ladder logic and PLC programming right here. All these checkboxes need to be unchecked. We need to leave access specifier blank, and we need to make sure that the implemented language is structured text. Now, all this stuff does mean something, and it's very important stuff. We're going to cover that later when we start diving into object-oriented programming more in depth. So, once you have all this filled out, we're going to hit Add. And that's going to go ahead and create a function block for us. Now, what this function block is going to do, what this module is going to do, it's going to compare two numbers, hence the name comparer. Now, it's very important that you understand what these var blocks do, as they are going to play a significant role in the input and outputs of your function of your new PLU that you're going to use inside of your ladder logic program. Essentially, the input and output are going to show up on the physical ladder logic diagram that we're going to be working with in the ladder logic side. The input, obviously, are the variables or values that you're going to input into the procedure, and the outputs are going to be what you're going to output from that particular block. The var, just in var, these guys right here, these are internal variables, meaning that they're not neither inputs nor are they outputs. They're just there to help with the internal processing of data. Now, typically, a function block is going to have an input values and output values. However, you're not always going to need these internal variables to help with the processing. So typically you can leave these blank, or if you're using something like bubble sort or whatever, and you want to create some internal variables, you can use these. However, like I said, for our purposes, we're just going to kind of focus on input and outputs. Now, oops, what happened? Here we go. This program is going to compare two values, two numbers, and if the first number is bigger than the second number, we're going to return true, else we're going to return false. Essentially, that's what we're going to that's what we're going to output. As you can tell, I'm a traditional programmer, so return's a part of my vernacular. So we're going to say input 1, we're going to set that to an integer, input 2, set that to an integer, and then we're going to come down to our var output and say result, and set that to a Boolean, and we're going to set that to false by default. So essentially, our function block is going to have two inputs and one output. This function block by default is going to assume the number input 2 is bigger than input 2 is bigger than input 1. You don't necessarily have to do that, but to kind of keep things easy and conceptually easy to picture in your head, we're going to go ahead and do that. So for the code, what we're going to do is we're going to say if input 1 is greater than input 2, then we're going to say that result is going to be toggled to true. Then we're going to put an else if in here. We're going to say input 2 is greater than input 1. Then result is going to be false. Now, essentially, this elif right here is going to help toggle between true and false to kind of help us reset our value after after input 1's been set to a value that's larger than input 2. So this is kind of going to help us go backwards. For lack of a better word. Now, a lot of programmers would probably use an else statement right here, and that is technically fine. However, when you're using a text-based programming language, you want to keep your else statement just like as a default, as like a catcher's mitt. If you can create a logic statement with, like, as we have here, input 2 greater than input 1 to kind of catch that other condition, it's better because it makes the program more specific. It makes it easier to troubleshoot, and it makes it just cleaner in general. And it leaves you with that else statement to kind of do error handling. So typically, a word from the wise, if you can describe your second case as a logical expression like we have right here, do so. So with that, this structured text module is now complete. The code is now complete. We have everything that we need. So we're going to come over here to PLC PRG, which again should be your ladder logic program. And we're going to come over here to PLUs, and we're going to take a compare block and drop it in. Here we go. Now, I want you guys to notice right here, we have input 1, input 2, and result. If you go back over to your function block file, you'll see that under the var input block, you have input 1, input 2, and under your var output block, you have, lo and behold, result. Just like we got here. So essentially, these are the variables that we declared in the function block. The input 1, input 2, and result. We also have this extra enable block, and you get that by default in CodeSys and other systems that are built on top of CodeSys. This is just basically turns the function block on or off. So we have to accommodate for that when we're writing out our variables. So with that, we're going to go ahead and start laying out this function block and laying out the program for it. So first thing we need to do is we need to set up a variable, which is kind of like this variable is a reference to this PLU, this function block. So we're just going to say C1 comparer. Next, we're going to say enable. We're going to set that to a Boolean or to a bool. I'm going to kind of line up my variables here to make it easier for you guys to read. Next, we're going to set result to a Boolean as well. And we're going to have num1, which is going to be an integer, and num2, which is also going to be another integer. Now, these are all the variables that we need to start hooking up our logic and our ladder logic rung down here. So we're going to click these little question marks. We're going to click select. We're going to click C1. And that variable is now going to be a reference to this particular function block. Next, we're going to set the enable. So we're going to set the enable guide to the enable contact. And input 1 is going to be assigned to num1. Input 2, as I'm sure you've guessed, is going to be assigned to num2. And finally, result is going to be result. And that is all we need to hook up this program. So now what we're going to do is we're going to go to online. We're going to click simulate. We're going to sign in, let everything do its thing. Kind of move this over so we can see it. And we're going to press the play button. Now we're going to go ahead and put enable to true and write that variable. Now, as you can see, this is already working. We don't have a logic statement to kind of pick up when these two values are equal. Again, that would be a good third else if to do something else, but since we're only doing true or false, we really don't need it. What we're going to do right now is we're going to set num1 and num2. So we're going to set num2 to equal to 3 and num1 equal to 53. We're going to write these variables, and lo and behold, our result toggle to true. Essentially, our code right here, as you can see, it's being shown in the output, is doing its thing. It's basically comparing the two numbers. These two the values that we wrote to these input numbers over here are now reflecting in our structured text code behind the scenes in our function block. So if we were to modify this and maybe say instead of 53, just write 1, our function block result toggles to false as expected. And if we go to the compare function block, as you can see, these numbers are also reflecting in this little variable section as well. So, moral of the story, there's not a big difference between utilizing function blocks written in structured text or ladder logic or whatever it may be. You use them the same way, the same rules apply. It's the big takeaway for this is if you got something fairly simple or fairly complex, it's a lot easier to go ahead and do the processing in structured text. As you can see, we can accomplish that in 1, 2, 3, 4, 5 lines of code. I guess I just could have seen the number right here, but I'm blind. We did that in 5 lines of code. We were to do that with custom ladder logic, barring another function block, compare function block, which I think already exists. It would take a lot more. It would be a lot more complex and a lot more awkward. So at the end of the day, there's your tutorial. There's how you integrate structured text with ladder logic and create little ladder logic functions and function blocks and procedures or whatever you want to call them with structured text. Simple, easy, and not much to it. All you have to understand is that to create a new ladder logic component, all you have to do is create a PLU, function block PLU, and then drag it on up, and you're good to go. So if you guys got any questions, please let me know. Please hit that like button, the subscribe button, turn on your notifications, and please leave a thumbs up, a like on this video. I'm a fledgling YouTuber, and I'm still really learning how to do this, hence the low quality production and the kind of talking over myself. So be nice. With that, keep an eye out if you're into this kind of stuff, because I'm going to be going over this more in the future, and we're going to be transitioning into more complex object-oriented concepts here in the coming weeks. So I'm the Computer Alchemist, and I'm going to bid you guys a good night. See you guys later.